Welcome to the next in our series, Awesome Admin Tech Talks. Our platform edition today is focused on getting data in, GDI. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customer, and want you to continue in your Splunk journey. Our experts help create these best practices, and we want you to leverage them in your daily role. Hello, I am Greg Daly. My role in Splunk is working as the Technical Marketing Manager, TMM, for platform technologies such as Splunk Enterprise, Splunk Cloud, and Data Stream Processor. I'm excited to share with you the information about getting data in, or how to get your infrastructure, systems, networking, application, and security data ingressed into your Splunk environment in a myriad of supported methods. Today's agenda includes the following regarding GDI: the ability to gather data from any Linux or Windows hosts, the best practices to create lossless Syslog ingress from practically any number of sources, how to create TCP data ingress over any port from any custom application or use case, using APIs to send or receive data, including data collection over HTTPS Event Collector, HEC, or HEC. And finally, using Cloud Data Manager for managing new data ingress to your Splunk Cloud services. Splunk has powerful admin capabilities that make it possible to manage Splunk at any scale. This means no matter how much data you need to analyze, Splunk can help. And we have the tools for admins to keep your environment secure and healthy. So first and foremost, Splunk system and data admins have a very important role in setting up Splunk to be used by a wider organizational audience. This involves a series of initial configuration activities, as well as ongoing management and monitoring of the use of the system to make sure that admins and users are getting the most out of Splunk's search capabilities. As admins, you get data into Splunk from your desired sources. Configure indexers and forwarders for your unique architecture. Once set up, you can add, manage, and create your own custom applications, as well as monitor usage and investigate user issues on an ongoing basis. As the admin, you will make sure that users and data is secure by managing users, roles, and the data they have access to. Additionally, you own data management, analysis, and the structure of the data for use by a wider Splunk audience. Let's break this into a few buckets that admins should focus on getting up to speed on a Splunk environment. Splunk allows for the ingress of virtually any data format. By far, the most popular and easiest ways to send data to an indexer is by installing the Universal Forwarder software on your Linux or Windows hosts. Universal Forwarders allow for easily sending lossless data streams of your files, logs, Windows event, Active Directory information, and some basic system performance counters. How to get data in. Here are the areas we'll be covering today during this Tech Talk. I will take you through a variety of proven methods that can be utilized in your Splunk environment. I'll be providing an overview along with some details on GDI, such as TCP port ingress, using APIs, Syslog, the right way, and using the Cloud Data Manager in Splunk Cloud to assist you with new data onboarding. So let's jump into the demo portion of today's Tech Talk. Let's start with Universal Forwarders. The ability to gather data from any Linux or Windows host or Solaris, AIX, macOS, or FreeBSD, is made possible with the use of the Splunk Universal Forwarder, or UF. The UF is an easy-to-install app and has a straightforward configuration process. The UF will run on practically any distro of Linux or any server or desktop version of Windows. The UF is a free piece of software you can download from Splunk.com. The Universal Forwarder's deployment as a server or workstation/endpoint software can be managed with a selection of methods. If you are in a small environment, and only in small environments will this be efficient and supportable, you can manually edit the configuration files for your UF installs. Input.com controls how the forwarder collects local data. Outputs.com controls how the forwarder sends data to the indexer, index cluster, load balancer, or other forwarder. ServerComp, that has the connection information and performance tuning for the data feeds. And Deployment Client Conf is to configure the connection between the deployment server that will act as the configuration head for all the UF instances in your environment. Administrators can also deploy the Universal Forwarder software by using your environment's own deployment tools such as Puppet, Chef on Nix, or the System Center Configuration Manager for Windows to push configuration changes and application updates. If you are a smaller DIY Windows shop, you could also build an installation wrapper for the Universal Forwarder and deploy the Universal Forwarder software via Active Directory assigned applications. Then you write your own PowerShell or Python scripts to edit and maintain the comp files on the managed host by role or even individually for complex one-offs like consolidated services VMs or something similar. The UF configurations allow to specifically target logs, files, and or folders to process and send to Splunk indexers or data stream processor. By the way, when I say send to indexer, I intend that to generically mean ingress the data through any supported method, whether that's an indexer, a heavy forwarder, or to data stream processor. Keep that in mind as we talk about ingress using various methods. The Universal Forwarder configurations will allow system and Splunk admins and engineers to select precisely the data they require while filtering out some of the noise that is not pertinent to IT ops, DevOps, security, business analyst, whomever. The UF configuration allows for hyper-specific targeting of local disk data. In Windows, the UF has a known, well-documented method to filter noisy and or low-value Windows events by event code, by content in the message field, or even turn off certain logs during testing and development completely by using the disabled equals true or disabled equals 1 setting that allows turning off entire stanza. A stanza is what represents, per se, a configured data feed. The best practices for Syslog. Now allow me to start this section with a disclaimer/explanation. Syslog needs to be done right. Many methods of collecting syslog are simply wrong and should never be used in a production environment. I will explain the simplest syslog method, then outside testing and learning labs, etc. I will tell you never ever ever do syslog this way. Then we'll talk about the big kahuna: clustered, containerized, scalable, robust, and lossless method of syslog routing and ingress. Simple yet unreliable syslog. Yes, on any Splunk installation. An administrator can go to data inputs, TCP or UDP, and configure and open up a port on 514. And you will get a syslog feed. A basic syslog feed at best that can't, and more importantly, will not survive a fault. The problem with sending Syslog over TCP 514 directly to your Splunk indexer is simply your maintenance windows. You should run your Splunk heads on Linux, my personal and tested recommendation. But just because you selected Ubuntu over Windows, that does not magically make your sudo apt-get update, upgrade, and reboot disappear. You still must patch your server and keep the system code up to date. Well, every time you reboot the indexer that was configured to receive TCP or UDP 514, you will miss network feed data over Syslog because your Splunk daemon obviously is not running during the reboot. An average environment could lose hundreds to hundreds of thousands of Syslog events in a single Splunk indexer reboot. That's a huge gap in the data. That's far from lossless data collection. And, very importantly, this is not supported or recommended by Splunk engineers. Any production environment should avoid using a direct-to-Splunk on 514 at all cost. You will lose Syslog events. Full stop. So how does an environment set up proper, supportable, lossless Syslog ingress as an infrastructure? Our solution is SC4S, Splunk Connect for Syslog. What is the challenge with Syslog? Well, there's actually a few to discuss. As we saw in the previous slide, Syslog is a protocol. It's not a source type. Multiple data formats right atop the protocol. Syslog presents its own unique set of challenges, especially when your Syslog ingress needs to scale. One of the data level issues with direct ingress to Splunk 514 that it globs all the 514 traffic as source type equals Syslog. That could be a problem for you in the future. Schema on the fly, aka Splunk's core methodology, is difficult to apply to source type equals Syslog. Source type equals Syslog forces the indexer into excessive resource utilization. Say this with me, folks. Direct Splunk at 514 does not scale. So to build out a reliable and lossless Syslog ingress, please use the SC4S method. Remember, Syslog is the Splunk superhighway of data. As more Syslog data is collected by Splunk users than any other data type, including WinEvent log security. If you've worked with WinSec logs before, you understand that the over-the-top verbose nature, size, and difficulties with that log type. And Syslog still surpasses WinEvent log security in volume of ingress. SC4S allows the Syslog feeds to be identified, parsed, and formatted, including auto-identification of the format. Now, I want to be very clear here on the topic of Syslog and SC4S. Syslog is often way over-engineered and sometimes at an insane level of complexity. SC4S will not solve 100% of the inherent Syslog problems for 100% of the use cases. But SC4S will properly address the problem of Syslog soup. Untagged, source type equals Syslog, and enrich your Syslog feeds with auto-detection to pan::logs, Cisco::ASA, making your Syslog data more intuitive and much easier to identify and manage properly. SC4S ships with predefined filters for many of the leading network and security devices common to enterprise environments. Splunk's partner community is already contributing filter development, and the SC4S project is in continuous improvement, continuous development mode. So updates will be routinely landing for users. As of the last update, SC4S is getting about 5 commits per week. SC4S is completely documented. It has its own GitHub repository and is actively being used by some of Splunk's largest customers, as well as a long list of smaller environments requiring lossless Syslog services. SC4S has a full conf talk, a GitHub repo, a blog. You gotta have a blog. And it has its own Slack user group, hashtag Splunk-connect-4-syslog at splunk-usergroups.slack.com. I can't reinforce this point enough today. SC4S is the only way to achieve scalable syslog ingress, including the ability to buffer to disk when required, like those system maintenance windows we discussed earlier in this talk. And it has the ability to send to many HEC endpoints. The ability to send to multiple HEC endpoints is critical since that is required for reliability and scale of the syslog data ingress so you can successfully collect the syslog feeds from practically any number of sources. And when you consider how many network switches, routers, firewalls, security cameras, digital entry controllers, printers, IoT devices, like HVAC sensors, etc., that are running in the typical engineered environment, syslog is critical and it must be processed as a critical data payload. How to create TCP data ingress over almost any port from any device, sensor, IoT play, or custom application. One of the many incredibly useful features of Splunk is the ability to set up practically any ingress on any TCP port. If you can send it, Splunk can receive it most of the time. Now, just to be technically clear, not every TCP port is available for use. Of course, you would not send data to a port configured for TCP 25, which is SMTP, or TCP 443, the web UI on SSL, but any other non-standard port. The ephemeral ports, those TCP and UDP ports above 1024, are the safest ones to assign to a custom data ingress. The configuration to assign a TCP port to the data ingress is straightforward and easy to understand and use. For those new to transports, remember, TCP is preferred over UDP, as UDP is a stateless protocol with no guarantee of delivery. When UDP packets are sent by a host or device, the transport assumes the destination is there, has a port open, and that the port can and is configured to receive and process the data flows. But that is only an assumption. By using TCP, you create stateful connections with the acknowledgement of the data packets. That's the big difference between UDP and TCP. The former assumes, the latter confirms, and then retries if needed. TCP connections are an excellent method to send data from custom applications, IoT devices, and many, many other use cases. This is the open door to allowing ingress from virtually any source, any app, any device, any use case. You can assign TCP port or TCP SSL using configuration stanzas in the inputs.conf. The TCP configuration allows the administrator to declare the host field, whether a fully qualified domain name or an IP address, which index the TCP port's data will route into, the source type. Note, if you don't declare the source type, Splunk will automatically fill that out based on various aspects of the data. You can also declare the source, but warning, don't override the source key unless it is absolutely required. Use the source type, tagging, and search wildcards before overriding this value. You can also set the index queue flags to process or not the TCP port's data with props.conf. You can also set the DNS translation flag if the admin wants to convert IP addresses to the DNS entry for readability, usability, or downstream coordination purposes. The TCP port configuration via the inputs.conf or the web UI, data imports, TCP or UDP, opens up the Splunk ingress to any idea your team or business has when it comes to receiving custom data. Virtually anything is possible with TCP port ingress. A quick personal story of using TCP ports. I use TCP ingress to collect text alerts, one-liner data from my do-it-yourself home security system. I use a freeware camera software that has a TCP send feature that allows you to easily push one-liner key value pairs in plain text about video or audio activities or trips. It was easy and the setup was less than 10 minutes, including setting up the TCP port on Splunk and configuring the key value pairs to send. Voila, I have data ingress. And for the warriors of the command line interface, the TCP port, like most features, is completely configurable in a shell or remote session. You can add, edit, remove, or list the TCP port configurations on the command line. Using APIs to send or receive data, including data collection over HTTPS Event Collector, HEC, or as we call it, HEC. Splunk's API framework allows for a rich, detailed, and customized REST endpoints. If your shop relies heavily on API connectivity to query, collect, send, or receive data, it is highly recommended you learn and use the information verbosely documented on dev.splunk.com. For the hardcore developers in the audience, Splunk has a large set of developer tools that enables teams to leverage Python, Java, JavaScript, and .NET/C#. With the SDKs, you can search your data, run saved searches, work with search jobs, manage Splunk configurations and objects, integrate search results into your applications, log in directly to your Splunk environment, and even do cool things like present a custom UI. Splunk Enterprise SDK for Java allows you to target Splunkd by making calls against the engine's REST API and accessing various Splunkd extension points, such as custom search commands, lookup functions, scripted inputs, and custom REST handlers. You can access objects by namespace, owner, app, and sharing mode, or a combination thereof. One of the advanced uses of the custom dev capabilities is to create custom search commands for apps in Splunk Cloud or Splunk Enterprise. Python is recommended for this development task, but there are specific instructions for using non-Python methods. You can call upon batch files, command files, executables, JavaScript, shell files, PowerShells, and PL files, as well as native Python code files. If you need to create a very specialized method to handle specific data formats, or even to collect data that has not been indexed yet by Splunk and include that in your workflow, these methods will help you. Additionally, Splunk provides the HEC Event Collector that enables data to be directly sent to a Splunk Enterprise or Splunk Cloud over HTTP or HTTPS. Of course, any production environment team should use HTTPS, SSL, to secure all connections. HEC is a token-based access control system, so you never, ever, ever have to hard code in your Splunk login credentials into your code. HEC allows you to send any application logging and or matrix to your Splunk instance in a highly efficient manner, which is secure and scalable. Setting up HEC is a simple task in the Splunk UI, using a few clicks and declaring, if needed, the source type, description, and output group. You can also set Enable Indexer Acknowledgement, But note, ensure your data source accepts ACKs from the indexer, depending on whether you're in enterprise or the cloud version. You can scale HEC by using the popular nginx load balancer with a straightforward setup for SSL configuration, targeting upstream servers, and tuning the workers for specific loads to your environment. Use an nginx standard configuration settings. You can manage load balancing methods, session persistence, and health checks. Of course, if you have a paid subscription with nginx, your team will be able to configure all the advanced nginx features and configuration settings. Next, for our Splunk Cloud customers, I would like to give you a quick briefing on a new feature that is rolling out to Splunk Cloud Services, Cloud Data Manager. Our cloud engineering team has been hard at work building out a new GDI experience. Cloud Data Manager is a tool that will make bringing new data into your Splunk Cloud environment easier, enabling bringing into the fold well-understood sources in a method with much less complexity. Why the new experience? The cloud engineering team is providing a cloud-first, cloud-native, and continuous development approach that provides a modern user experience, again, with a lot less complexity. Being able to process new data is critical to all environments. Onboarding, including ETL, can be time-consuming and a laborious process. When looking to onboard, for example, AWS data feeds, you must deal with AWS-specific issues, multiple services, regions, and accounts. Cloud Data Manager takes into account these complexities and provides a well-defined process that allows users with minimal AWS experience to be able to successfully bring the AWS data flows into your environment. This reduces the time to value with your newly onboarded data to a few minutes instead of hours or days. How we got to Cloud Data Manager? Cloud Data Manager is a major development effort for our cloud engineers and product managers. Splunk engaged our customers, receiving direct feedback from our users and Splunk admins and SEs in the field. We engaged AWS product managers and solution architects. This is an effort laser focused at the Splunk admin and the AWS admin. And the best practices for this offering comes from AWS itself. AWS and Splunk are huge partners and have been working hard to maximize the latest best practices at all levels for your AWS and your Splunk Cloud experience. As you saw on the first Cloud Data Manager slide, the cloud team has teed up AWS, Google Services, and Office 365. At Splunk, as you saw with SC4S and Syslog, we work hard at addressing the large and even the largest scale problems that our customers face in day-to-day operations. Remember, in addition to the work AWS team members and the cloud team members here at Splunk, we gleaned a great amount of data and information from the telemetry returns from Splunk installations around the world. That phone home usage information is extraordinarily helpful in the support of current products and insight into our customers' future needs. That helps our team bring new innovative features and methods like the Cloud Data Manager to your businesses. As I remind everyone during these tech talks, up your Splunk game, attend training, get certified. Please take advantage of the vast resources at docs, devs, and answers.splunk.com. Watch Splunk Live events. Attend your local or remote user group meetings that occur literally all around the world. And please join us virtually or in person in Las Vegas for Conf 21, where we'll go into deep admin capabilities and have detailed presentations of a variety of our products and offering. I will say it again, community.splunk.com is your friend. Splunk users can ask questions, share ideas and best practices, and a great forum experience. I am Greg Daly, TMM for Platforms. I thank you for attending today's Tech Talk. I look forward to our next session of Admin Talks. Have a great day.